go to your y equals button. We are going to graph the function y equals the absolute value of x. So first you need to know how to get into the y equals screen where you actually enter equations. If you see anything in here from previous classes, just clear it all out. If you need to arrow down and press clear, do whatever, make sure that there's nothing in here. Okay, to get absolute value, there's two ways to do this, and in your notes it shows you the two ways. This is the way I prefer because it's the same on all of the calculators. So you're in your y equals button, you need to push the math button, and then right arrow to move over to the number menu. And then which one do you think is absolute value? Abs. So push enter. And your calculator does this really cool thing where it changes it to absolute value bars and makes it perfectly ready for you to enter stuff in there. How do we get an X inside those bars? The X is this button right next to the alpha button. Do you see what your cursor looks like right now? That means to get out of the absolute value bars, you'd push the right arrow, or you could push enter to move down to the next row. But now we have y equals the absolute value of x in our calculator. So one more time, y equals button, and then math, arrow to the right, abs, that gives you absolute value. If you have a slightly older calculator, instead of those pretty little absolute value bars, it might say abs parentheses, and then whatever you put inside the parentheses, that's what's inside the absolute value bars. Okay, how do we actually graph? There's a button that says graph. It's on the top right button. Push graph, watch the magic. Okay. Does this graph surprise you? Yes? No? Maybe so? Think about absolute value. Absolute value turns every single number positive. So the absolute value of -5 would be +5. The absolute value of a positive number is positive. The absolute value of a negative number is positive. So that's a V shape with all of the y values being positive numbers. On our paper, let's kind of copy this. So the point at 0, 0 is called the vertex. And I like to call it like a slope of 1. This graph has a slope of 1. If you look at this graph, every time you go up, the graph goes out 1. So up 1, out 1, up 1, out 1 to make the V. So up 1, out 1. And then from there, up 1, out 1, and there's our V shape. Okay, this is called the parent function. The parent function is the simplest version of any particular function. So y equals the absolute value of x is the parent. It's the most original absolute value function. Now we're going to look at what happens when we do stuff to the equation y equals the absolute value of x. Like, what happens if we put a 2 in front of it? So the really cool thing about this calculator, you don't have to clear out that old equation. Leave it there. Go down to y2 equals, push the y equals button. This time we want to punch the 2 first, and then get the absolute value of x. Do you remember how to get absolute value of x? Math button, arrow over, enter, x button. So get your screen to look like this, and then push the graph button and watch the magic. What do you notice about this new graph? It's what? It's more, I'm seeing a lot of people using their hands to describe because we don't have words. Steep is a really good word. It's steeper. And think about that number 2. So instead of up 1, out 1, let's look at what this graph is doing. up 2, out 1. So is it kind of still like slope? Yeah. So from this vertex, up 2, out 1, up 2, out 1, and so on. This one is more narrow. And I'm going to jot myself a note in that graph to tell myself how this is different from the parent function. Back to y equals, and I'm going to leave everything in there. To put in 1/2 times the absolute value of x, parentheses 1 divided by 2, that's the best way to get that fraction in there. And then absolute value of x. Get your screen to look like that. This is one. And then graph. And our guess was correct. This made a wider graph. So from that vertex, up 1, out 2, that makes a much wider graph. This particular graph, because there's a negative in front of the absolute value bars, it flips that graph over the x-axis. It's actually a vertical reflection. I want you to notice that it is the same width as y equals 2 times the absolute value of x. So the fact that there's still a 2 in front of the absolute value bars, that's going to be the same. The a value multiplied in front of the absolute value function affects how wide or narrow the graph is. It also affects whether it opens up like a V shape or opens down, kind of like a mountain. So let's put some explanation in here. If that a value is larger than 1, like 2, 3, 4, numbers bigger than 1, it's going to be more narrow. If a is less than 1, like fractions or decimals, it's going to be wider. And if a is negative, it's going to make it open down, like that. Now let's explore what happens when we add or subtract inside the absolute value bars. Does anyone have a guess what you think is going to happen if we put -3 with the x inside the absolute value bars? It's going to move left is the guess. So let's plug this into the calculator and find out what happens. In your y equals, leave the first one in there, clear out the others. We want that parent function in there so we can compare. So we are graphing the absolute value of x minus 3. And again, the guess from my 4th hour class was that this graph is going to move left. At least that was the guess from a person or 2 or 3. Let's see what happens. So the blue one is our parent function. The red one is our new function. What happened? It moved over 3, but which direction? Right. That's kind of weird, isn't it? Whoa, what just happened? I don't know what just happened. What is going on? My screen's freaking out. So if this minus in the absolute value bars moves the graph to the right, that is a little bit confusing. It says minus, but it moved the graph to the right. So what do you think adding 3 inside the absolute value bars is going to do? Move it to the left. So let's try that. If you want to, you can just go in here and change that minus to a plus. Okay, original y equals absolute value of x, and then here comes y equals absolute value of x plus 3. Plus 3 did indeed move this to the left. So what effect does a number added or subtracted from the x have on the graph? It moves the graph left or right, but we definitely need to put some explanation in here. If we're adding, it actually moves the graph to the left. If we are subtracting, it moves the graph to the right. If this seems backwards to you, it is. Imagine inside the absolute value bars are like the walls of a circus tent, and everything inside those absolute value bars is crazy town messed up backwards. So inside the absolute value bars, it's backwards. If you see minus, it means right. If you see plus, it means left. Okay, take a guess. What do you think adding 2 outside of the absolute value bars is going to do? Our guess is up. Is that our guess? Test it out, see what happens, and then try minus, see what happens. Get those graphs on your paper, and then we'll talk in a second about this bottom part. So adding 2 outside of the absolute value bars moves the graph up 2. Subtracting 2 outside of the absolute value bars moves the graph down 2. So that's nice, at least, that the stuff outside of the absolute value bars is perfectly normal. Plus means up, minus means down. Inside the absolute value bars, crazy town backwards. Outside of the absolute value bars, perfectly normal. So right down at the bottom, this plus k moves the graph up or down. And just like normal, plus moves it up, minus moves it down. On your assignment, I'm going to give you absolute value equations that look like this. And you're going to have to figure out, how does this graph differ from y equals the absolute value of x? So we'll think about each piece. First of all, the negative. What's that negative going to do to the graph? Make it upside down. So it's going to open down. It's going to be an upside down V shape. How about the 1/3? Is that going to make it wider or narrower or the same as just a plain y equals absolute value of x? Wider. How about the +2? What's that going to do? Left 2 units, and the +5, up 5 units. So for the assignment, you should not need to use the graphing calculator. You should be able to just look at the function and figure out all of these pieces. If you'd like to check yourself with the graphing calculator, you may, but you don't have to.